Okay, recording has started. And sharing. Cool. So, okay, we can start. So, hi again. My name is Victoria. Nice to see two of us here. Today we're going to talk about Redux, how it's helpful for us. We're going to start not with Redux itself, but more with design patterns that lead to creation of the Redux, how it was created. We'll discuss main principles of Redux or main entities of Redux and stuff like that. So, when I've been talking about React, I've told you about MVC, that is a pattern, design pattern that was a building block of React itself. Flux is also a design pattern that was used to create the library Redux, though Flux itself was built on top of the MVC design pattern. So let's discuss a bit what design patterns are in general and talk about MVC and Flux before starting a discussion about Redux. So if you don't know, design patterns are used for our convenience, for convenience of developers to solve certain problems that other developers already stumbled upon, that they faced already, and created some sort of design solution for that problem. So that's why we use and need design patterns. MVC is one of them. So MVC stands for Model View Controller. And as you can see here on this on the schema, this is a kind of a data flow of the design pattern. So we have controller. Now let's start from view. So view is a UI of your application, basically everything that user sees. Okay, let me try again to share. How about now? Cool, sorry for that. So yeah, on the schema, we have view. This is everything that user sees on our page, basically our UI. Model is data that is used by your application. So maybe some collection of items in an array, some configuration of your application, language of your website, stuff like that. So everything that you store in your application would be represented in a model. And the controller is kind of a thing that's connects this to entities, model and view. So basically when user does something on the view, clicks a button, types something in input, even scrolls down, view will send some action, some event to a controller saying that, hey, user did something, react. Controller then updates some data in a model and notifies our view. Same here, you can sometimes modify models. So that's how we modify a model. Yeah, so here model updated view, as in a React would do with props, for example. So user clicks on button, React reacts, controller here, our component somehow updates state of the component, like toggled on, toggled off, view changes. This is kind of notification. The same here, view can do some queries, some requests, for example. So that's how the model will be updated, and again, view would be some kind of notified. So that's kind of a bi-directional flow of the data. And in MVC pattern, there can be multiple controllers, multiple models, views, or kind of this tangled structure. And everything should be somehow connected, everything should be updated. One can be influenced by another. So imagine we store some data here that on change should modify not only one view that is directly connected, but the second one, and maybe this one at some point, or change of the model here can influence model here. That's not really straightforward representation. This sometimes can be really tangled and hard to understand at some point. That's why we at some point came to the design pattern called flags. Here we have only one view at this schema. In future we can work with the multiple view, but here if we talk about only one view, same here, we do some event was called on a view, click on a button, the action was created, some kind of click on the button action with maybe some data passed. This action comes in the dispatcher, in action dispatcher. This dispatcher called changes in our model, or here we have store instead of a model. So same here. And again, we as we can see here, we don't have multiple controllers as we had with MVC. We have only one dispatcher, and every view sends action in this dispatcher. We then orchestrate where should this thing go and which view should be changed. This design pattern was used by Facebook before they started using Redux, and they came to the problem when before updating of the page, or yeah, so basically imagine the situation. You have kind of a window with your messages here somewhere in the corner of your application, and here in the top we usually have like a few icons like navigation and icon with the number of messages you get. So basically the problem with flags was that every time message came to the user, here he could see it, react to it somehow, but the count on the icon didn't change at all, because this kind of data has been stored in one store, and it should have been connected to multiple views and stuff like that. So this is just one example of why flags didn't really work with Facebook. That's why they started Redux. Redux is different from MVC and flags in a way that this is not a design pattern already. It's a library, and it's just implementation of the flags design pattern, but with a certain features. So here you can see we still have store, we have view, action, stuff like that. We have our dispatcher. Here, yeah, mostly we would have here in Redux we usually call this sort of thing not dispatcher but reducer, but the same thing here. So we have view, call an action, event happen, action created, comes into dispatcher, dispatcher somehow, reducer somehow reacts and change our store. That's how it will go. Plus actions can come directly, not from the view directly, but outside, for example, because of some calculation changes or request came and stuff like that. So as you can see here in Redux, we don't have multiple stores. We have only one store all the time, one dispatcher or reducer. Everything else is the same as in Flux, except for amount of stores. That's how we could manipulate data unifically, from one source. So basically, we have one source of truth that could have helped us avoid this problem where we stored messages in one store and count of messages in another store, and for some reason we didn't update count of messages, but updated messages itself. So imagine updating different data in different stores. Not really handy. So that's why Redux come in hand. Yet again, we come into a problem with the props drilling that we discussed in lectures of the React when we have some state in our main component application. Usually it's handy to store it there to sort of pass it up and down and have single source of truth as we have with Redux before we use something like that. And sometimes when we have really deep nesting of the component, we're faced with props drilling. One way to solve this problem to use context API that comes with React. Another way of solving this using Redux, we kind of have a single entity of state, or we call it store, of the application, and we have access to this store from any component we want to. So, yeah. So in Redux, we have a few main elements of Redux. Store, we discussed it already. Action, this is the thing that has been called dispatcher in the schema. Reducer, and basically, yeah, view, simple as that. Store hold the whole state of tree. Simple as that. The only way to change the state is to dispatch an action, like here from view or from somewhere else, from your application, for example. You can simply do that. Storage in the class, it's some kind of an object that stores your data and some properties. It's really simple entity. To create store, pass your root reducing function to create store. We'll talk about it later. It's more of an implicational thing. So basically, store is immutable. So here, this states for one quality of the store that it is immutable. Basically, we cannot directly change store, same as we cannot change state of the component directly. Same here, it's also state but of your application, and we do not change it directly because basically all this schema there won't work. We cannot just from somewhere else change store and expect our views to be updated. That won't work, unfortunately. Yes, as in Redux, we don't have multiple stores. Every data of your application would be in your state, though Redux gives you sources and tools to visually separate different parts of stores. So for you as a developer, that would be easier to work with different parts of store and don't make a bulky kind of structure where everything held. So after compilation, Redux will combine it for you. So basically how we would work and create our store in Redux. Importing create store function from Redux library. We create some kind of root reducer. See here, reducer is a function, and it has a really important quality that it is pure function. So pure function is a term from functional programming. It basically means that pure function is a function that doesn't have any side effects. So everything that comes, so function that gets certain attributes every single time will return the same result. So if I have a function and I pass 1, 2 in this function as an argument, every time I call this function, I expect to return it the same exact value. So pure function shouldn't use variables from outside of the scope. Pure function shouldn't do any side effects like API calls and stuff like that. Yep, so pay attention when you create reducer, and I'll show you how reducer can look like later. Yep, so we create object of initial state of our application. Usually it's just a empty object with empty properties. And we create store itself. We use create store function. We pass reducer as our first argument and initial state as our second argument. Simple as that. So to manipulate store, we create actions. And as you can see here, we don't really pass to dispatcher action. We pass action creator. So let me just, there is a little bit of a difference between action and action creator, and we'll talk about it later. But starting with action, it's object. Action is a simple object that has property type and property payload. Payload is an information that sends data from your application to your store, so you can hold there something you want to put in your store, or something that can be used by reducer to decide how to manipulate store. For example, true false toggle that would tell reducer, hey, if it's true, pass this data that you already have. If it's false, do that, or for example, remove data and stuff like that. Actions are the only source of information for the store. Again, actions tell reducer how store should be manipulated based on a type and payload. And you send them to store using store dispatch. So when we work with Redux, we say that we dispatch some action basically. And this is an example of our action. So it's have type, some string that holds name of certain action, and payload. You can put here any data you want, some string, some simple object. It doesn't have to be an object. It can be just a string if you want, though usually we stick to the object syntaxes in always when we pass payload, just to simplify things and know that how to work with that. So here in our example, we created store. And again, we're creating some kind of an action. Here we didn't bother ourselves to create our action separately, so here in this brackets our action itself, we pass type. As you can see here, we didn't pass payload property itself, so React doesn't bound you to certain properties. So basically action is just an object. It should have type and payload, so you can put these two properties in any property you want. You can name it whatever you like, though again in React Redux community we usually stick to this naming just for sake of understanding between developers. So basically type, payload, we dispatched action to the store, and now reducer have to react some sort of way. We'll look at this a bit later, how we can basically catch this dispatched action in our reducer. Yet again, looking at this action, it's not really it's hard to imagine how we can work dynamically with action. We don't want to create like 100 millions of objects that represent action. Because we sometimes want to pass payload dynamically. Sometimes we want to get data from the server and put in payload. If we create an object beforehand, how we can do that? And This is where action creator come in hand. Basically, action creator is a function that creates action, simply as that. So here, again, we created our store, we created type of our action, and here on line 11 till 14, we can see action creator. So basically a function that gets, here it gets some data for a payload, and it passes this data in the payload property of our action. Every time we call this function, it will create new object with type add to do and a new payload. Here, as you can see, we dispatched action add to do with payload to do 1 and then with payload to do 2. That's how we work with actions and create dynamically our action that we need. So here you can put anything you want from any source you got this data. So talking about reducer itself. Reducer specify how the application state changes in response to action sent to store. I hope we already got this. And given the same arguments, it should calculate this next state and return it. So every time we give arguments, it should basically give us the same result. This is an important thing, don't forget about it, but you'll be given certain syntaxes of how you can write reducer, so you don't need to think about it all the time. So basically a reducer is a thing that decides how store should be changed, and here you can see we dispatch our action somehow, it's passed to reducer, some calculation happen, used, and as you can see here, reducer returns new state of the application, and this is really important. Remember, I told you before that we do not mutate our store, yeah, when we work with Redux. Even when we pass some action to our reducer, dispatch action to our reducer, reducer does not mutate state. It creates new state of our application, new store, and replace our previous state with a new one. So even reducer doesn't mutate state. So here is an example of reducer. Again, we created some sort of store already with a more complicated initial state. Yep, we're creating our reducer. So as you can see here, this function gets state, some initial state, usually provided in this function as well, in order to display something when one application loads for the first time, and we get in this function action. So basically we catch action in reducer and can work with it. Usually we define our reducer in using switch. So we kind of switch between different action types, and on certain action types we do certain things. So here, as you can see, on add to do action, we return new state. Here we destruct previous state and change certain property of it. We return new state that would replace our previous state, and change our to-dos. Here in this syntax, again, we use a previous to-dos that we already had, we destruct them, and add a new to-do from action payload here. Simple as that. Pay attention that we usually also add the default state of the property if none of the action type match any that we have in our reducer. Previous version of the state should be returned. Yeah, so as I told you before, Redux allows us to gives us tools to work with with our state separately. We do not have to have visually, we don't have to have one reducer. So after compilation of our building of our application, after building of our application, we still will end up with one reducer, with one store and stuff like that. Here, visually, for our own comfort, we can split our reducers into multiple. So here we have initial state, we have some kind of a root reducer, and we have login action, logout action, add to do, delete to do. These two groups of action doesn't belong really together. They look like a separate sorts of entities in the store or types of actions. Yeah, we would like to split them to separate reducers or separate files at least. So Redux allows us to do that. It will kind of pass our dispatcher through all of the reducers and match it in a certain place. So here we have our login reducer. We call it users.js. We have stuff here. We just export our function, which stands for our reducer, out of this file. We have file for to-dos reducer. We store here everything that we want that connected to work with to-dos actions, and in the index file of our reducer, we combine them. We basically import these two functions. We use combined reducers function from the Redux library, and we export here using this function. So it will combine these two reducers in one for us. Simple, handy, cool thing. Yep, so this is basically it for what is connected to Redux entities and stuff like that. On the next lecture, we're going to talk about principles of React, how they're represented in the Redux itself. We'll talk about the certain library, React Redux, and how it can help us to work with it, because out of the box, it's hard to think of how we can connect everything together, because Redux, just a library, for its own, it does not connect it to Redux. We can connect to React, sorry. We can connect Redux to Angular, to Vue, to the application that doesn't have any framework at all. It's just a library to store to state management. Yeah. Somehow we want our components to react to changes in the store, and that's where React Redux library comes in hand. We also will talk about some advanced topic, personal container components, how they connected and stuff like that. So now I want to show you again. No. I want to show you an example of the file structure that you might want to have organizing your Redux, just for your own comfort, and it will also help you to understand how different entities of Redux look like, how they are separate from other and stuff like that. So let me just link to this repository was added to your home task, so don't worry if you want to look at this once again, you have an access to it. So here I have a separate folder with a store, and as you can see here, in every single file I have and store different entities of Redux. Of course, in the big applications, you won't these files might be giant. So probably every single file that you can see here can be a folder, for example, that would store separate reducers, for example, and separate action types for separate reducers and separate action creators for separate reducers. So basically, you can look at that reducer is the starting point of your separation here. So let's start with okay, let's start from action types. So when we work with Redux, we in actions we pass type of the action as a string here. So there is a good practice that was created in React Redux community to store action types in separate file in the constant that named the same as the name of the action itself. Why seems like additional useless work? Because you will use this string at least in two places when you use action creator and in the when you create action when in action creator and in the reducer at least two times. Maybe you would have separate reducers with that would react differently. I don't know. So at least two places already. Writing strings might lead to certain mistakes, and your IDM won't tell you about this. So if you make a typo in the name of your action, VS Code or wherever you use won't tell you that, hey, this string doesn't belong to the name of the action. Though if you make mistakes in the name of the variable, it will tell you. So basically, that's how we would avoid typo errors and spending few hours and finding an error and ending up understanding that it was just a typo. So that's one reason why we do that. The second one, again, we use action name at least in two places. So for example, if we decide to change the name, we can do this in this one place and it will be changed all around the application. So that's another reason. Action types we use in actions creators, and here example of simple action creator. As you can see, they are all the same. In the next lecture, we'll talk about how we can make a process of creating similar functions simpler, because there are some libraries that can provide you tools to create actions for you. So stuff like that. We export actions creators from outside of these files, and again, action types we use in reducer. So yet again, we create our initial state, we pass this as a replacement for a state that wasn't passed for some reason, for example, for initial load and stuff like that. Here we use switch case, we have different types of actions, stuff like that. So it doesn't have an example, but sometimes we can have similar actions doing the same things. For example, replacing to-do items. That might happen sometimes. You don't need to write separate case for this new action to do the same thing as the other one. You just need to add this case name of the action before this sort of line, and it will kind of go this just the syntax of a switch. So as you can see here in reducer, I somehow manipulate with the payload with data that came. So to-do items came from state somehow. Maybe here you can see I toggle to do, so I use action payload. In action payload, I send the ID of the to-do item that I want to toggle on or off. I use data from my state, sorry, or store, wherever, to find this to-do item and toggle it. So here again, I do not use any function that can mutate my data. So map creates new object, new array after it's complete. So here, as you can see, I did not manipulate this, mutate this structure. I created a new one, and this is a really important reason, really important point that you want to remember from working with Redux and Reducer itself. You do not mutate store in any way. You should be really careful with the function that you use. Again, as you can see here, to delete some to do, I used filter. I did not use some props, I don't know, slice function that just changed the existing structure. I use filter that create new structure and replace my previous store with a new one. This is a rule that we should always remember working in Reducer of the Redux. Yep. So yeah, Reducer. One more, few more file that might look new for you, selectors. This is again for our sake. We will get certain properties from store all over our application in our components. We might do this, get this to-do item several times across the application. So imagine situation where we want to move this array of data somewhere else in one layer deeper in our store, or in completely different object property in our store and stuff like that. We would need to change it all over our application. Again, selectors come in hand here for us and allow us to create function that would return your property once and just reuse this selector all over our application. And again, if we would need to change location of this data, we do this in one place and it will be changed all over the application, like simply like that. Thanks. So Reducer and everything that we do inside a reducer is synchronous. We cannot call, for example, do backend calls or some API calls just from scratch without using anything additional in reducer. Therefore, there are some library that you can use for that sake to add to Redux in order to use some asynchronous actions to add to your actions and stuff like that. So we'll talk about them again on the next lecture, I believe. Yeah, we should. So yeah, again, this things, as you can see, of wrappers around our action creators. So we again still dispatching our actions. Here we return action and get to the creator. We dispatch it in our thunk, though as you can see we do some asynchronous action inside it, and the syntax of it is very specific. Specific is a function that returns other function, and that's what originally stands for thunk. It's just a function that returns other functions. So this function would be used by some libraries in order to make stuff asynchronously. So this is just a certain syntax. When we talk about these libraries, you'll get why this is like that. Yeah, and everything connects. Basically, most of the files that we looked around connects in this index file. As you can see here, we have some functions from the Redux library itself, like create, store, apply, middleware, compose. We'll talk about this too right now. Thunk, again, this is a library that allows us to do asynchronous actions in the Redux. We'll talk about it in the next lecture. And we import our root reducer here from this thing. Again, if you want to separate some actions, you are free to use Redux Redux reducer splitting. Yep, so here we pass initial state. Here we pass initial state. We get initial state in our state as an argument. We work with some middleware here. This don't bother with this for now. This line. This would allow you to work with React DevTools. Redux DevTools. I don't think I have them here. Basically, this thing will visualize for you everything that happens in Redux state. You would see this in a really convenient way. Every time some action happened, you will see this in the kind of list. Yeah, this thing. So you install it. You need to do to add certain this thing to your application when you create Redux, and this will work on its own. This thing is for adding middlewares. Here it's just to add chunk. Again, don't bother yourself for now. And a line that we already saw that use create store. We pass here reducer, initial state if we get it, or empty object. This is just a fallback, and enhancer is the last property. Again, don't bother yourself here. So we returned our store, and we will use it in here. Here. Yep. So as you can see here, this thing that I returned from the index from the store is not really an object as we saw in our presentation, but it's here we get an object from create store. It's a function that I expect to use later in my index file of the React in order to pass some, I don't know, index state, initial state, and stuff like that. So that's just a convenient way to do it. Again, you don't have to do this. You can return from your store file just an object and use it here. This is this thing for our next lecture, how to connect Redux and React. We'll talk about all of this later. So yeah, I believe that's it. That's it for today's lecture. If you have any questions, feel free to ask them. Okay, not going anywhere. Okay, do you have any live coding videos of this to the list? I don't, but I believe I used some video to do that. So what there's one source that I really liked to use when I've been learning Redux, React, and stuff like that myself. I hope nothing inappropriate comes there. Yeah, let's do like this. So React, how this was React. Okay, let's try searching like this. I don't really remember how this goes. name is, yeah, React Crash, yeah, Traverse Media, this guy. So he does a lot of videos. He do crash course every year for a lot of technologies, including React and Redux. I really like how he explained things, and I believe he does live coding too. Yeah, so here as you can see a lot of stuff he does with live coding and explains stuff from React. And 3 years ago, maybe something more fresh, though I don't think that a lot of things changed. Is it a to-do? I have no idea. Post reducer, post action, page posts. No, it's a bit different, different application. Though again, I really like how he explains and he shows you like live coding as you went. So yeah. Though he starts right away from components, working with components. So maybe you'd like to watch him a bit later after our next lecture. So yeah, yet again, Redux is a separate entity. You can start working with this without Redux even. You can add this to your application without any framework. I believe there is a course on Linda, but it's a LinkedIn thing, but I think it's paid, so I cannot recommend this for you. So yeah, Traverse Media, cool guy, recommend him. Maybe some other questions. I started home task and having troubles with environment. Husky hook executes npm test that hangs. Husky hook executes npm test. That shouldn't happen if you wrote, if you didn't add your tests to the hook. Can you do you have an open repository for that or stuff like that? Or you can send me in the chat how you, default one, so you didn't do anything. That's interesting. Let's go to Husky. I didn't face with anything like that before. So regular execution of npm test runs in watch mode. Probably it's when I can press enter Q to proceed. Maybe that's more of not a Husky problem, but Create React. Did you use Create React app for you to create your application? Okay, let's check. Probably something test. Maybe we can go and do. Oh no, I don't have a Visual Studio on that computer. Okay, create React app. Testing watch mode. Okay, just give me just a second. I switched to different computer. Stop sharing here. Close everything. We'll just try doing quick. How to do. Okay. So great. Let's go to desktop and create. X create React app. Oops. Yeah, I forgot to. We'll just try to do a simple check for this. This would be simpler. Because last time I used Husky for my pet project was quite a while ago. Because it was quite a lot of time before now when I started new project. Yeah, this always takes a while. Oh no. Crap. I lost my desktop. Okay, so let's open it here. Yeah, I cannot do this. Open. Desktop. Test. Open. Okay, so we have our application. Let's install Husky. Husky. Great. So what did you do next? So we have our application, we have Husky, we have test, probably simple one. So what's next? Did you add anything or just? Them said script prepare Husky install npm run prepare. Okay, I see. Okay, you're using just comments from the Husky side. Cool. Let's try them out. Where is meeting? Oh, it's here. Chat. Great. We add hook. Cool. Let's try this. Pre-commit npm test. Yeah, so you're running npm test. That's it, okay? That's what you have, so you can run. Crap. Where is this chat again? So next thing you do is you committing and tests are running. Yeah, that's the problem. Mm-hmm. Okay. This is what you get. I'm expecting. Yeah, great. So this is an expected behavior because pre-commit this file that was created by Husky will run this this script from package.json on before committing and before pushing. So as here you can see, you're basically running tests and npm tests. That's an expected thing that will happen every time because this what it says. So what you want to do here, so it would run this comment every time you're committing automatically. So what you want to do is create some command and yes, and will work. Interesting. And so you want to add ESLint to your application. You want to create script in package.json named lint or whatever you like that would run ESLint for you. You check that it works by running npm lint in your console. If it works, probably npm ESLint. If it works, great. You can then add it to your pre-commit, and here you replace this script with the one you want to be run in before committing. So like that. So this is why it was running tests before before commit, because you basically example from the Husky documentation adds test scripts for you. Yeah, that's what do. Lint staged blah 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 pre-tier right. What is that exactly? Quick dragged up setting up your editor. Yeah. Let's check it. That's from yeah. Yada yada, in replacing. We don't want to Visual Studio Code configuration, WebStorm. So hey, Husky lint stage pre-tier. Okay. husky hooks pre-commit. So here, as you can see, this is example for husky previous version, because this is how we did it before. We didn't have all these fancy commands and separate folder for husky and stuff like that. We just had to add this in package.json file. Not sure if it will work now or not, though. This here is just a configuration for lint staged. It can be added in separate file. If you go to this, so this is just a configuration, it's not a script. Scripts basically are here. It's everything that you can run in your console with npm before this. So npm start, npm build, it's all script. Same here with lint. So lint staged is just an additional library that you can install from npm. Run linters against staged, get files, and don't let something slip into your code base. It's again for something that you staged, you add to in your Git basically. For running npm, give me just a second. npm run lint. For just running lint, you don't have to install anything additional. So idea is the linter not to run tests with husky. Test is separate thing bit, so it's like it doesn't connect it to linter anyway. Linter just to check how you create your variables, if you used some deprecated lines or names, if you put your semicolons in a certain way and stuff like that. So you don't want to run tests if you didn't write them for the first thing, and you don't want to run your tests on commit, definitely. So here it should be running linter, and okay, so I added ESLint in my rep repo, and I added it like this to my script. It runs, but it doesn't show any errors. Let's see. Will it tell anything? No. Cool. Create React app, yes, and it's for editor setup. It's not, won't help us in the start. Visual Studio. Yeah, let's check this out. So yes, yeah, create React app comes with ESLint. But how to add this? How to extend it? You need to integrate it with your IDE. How to run it? After integrating it, an ESLint server will be running in the background and will enable linting for your IDE. You create a tab, but I want to run it as a script. Integrate it with extension and setting as JSON. If you open debug mode, you can check. Let's try this one. Maybe I forgot path is needed. So, project created with creator tab will have React script. React script has ESLint. Yeah. So, project made with creator tab does come with ESLint. Great, yeah, we know that. As a dependency, not something global instead. Lint, then npm run lint dash. We make the command ESLint ignore path. Similar ESLint config and start. So it runs, but it doesn't show any errors. How come? Yeah, okay, that's not quite. So basically, I want to spend time now checking out why this doesn't work. Though, again, answering your question, what you write here will be run on before you commit. So everything you need to do is just set up ESLint for your application. Again, if you use Create React App, this will come separately. So basically something like this should be added to your application and be run for pre-commit. You can move testing npm run npm test to sorry, this would be like npm run lint. You can move your test in pre-push hook, though for now, as you don't have any tests, this doesn't make any sense. This is something for future. Let me just check. So here, yeah, before we had little bit different syntax. So flow lint, yeah, you write lint and pass the path. It would be run for your stuff like that. So that's why you stuck. You just don't need to run tests. Cool. Hope I helped. Sorry, this linter thing doesn't work. Live coding and streams doesn't really work for some reason. Cool. Yeah, great. Do you maybe have any other questions? I can explain. You have some time. Okay, I guess not. Cool. Great. Yeah, thank you guys for participating, and yeah, have a nice evening. Bye bye.